Hello, everybody. I hope everybody had a good spring break. Came back yesterday, and that assignment from the previous module, when I made that assignment, I thought, well, the Thursday after spring break sounds good, but after a week off, that's going to be coming up soon. So I can push that date back a little bit. We need a little more. So don't feel rushed on that one. The next assignment, the stuff we're going to start into tonight, is almost trivial. So if the prerequisites for this course hadn't included Python, it would be a good, the next coming homework assignment would be a good one, because it's, well, the next section's writing files and tuples and dictionaries and recursion. There's a few things in there. We're talking about writing files tonight, and that's what all the homework in the next section is. So when these statewide course shells come together, you have to put them together under the assumption that people haven't had Python before. But everybody in here has had Python before. So with that assumption that has to be made when they made it, a first approach of writing files in Python is going to be simple text files. Just write your data to a sequential file, or read a text file and do something with the string you get out of the text file. Something I believe everybody in here would have seen in the SDEV 140 class. And I started to add some more complicated things in the assignment, and I was like, oh, that's probably a good relaxed thing. Because that one that I assigned right before spring break, there was quite a bit to it. So might as well keep it small. But I still wanted to talk about files, because there's some important aspects of that. Right? So first half of this semester, we were looking at Python and just going through the syntax and the basic ideas of it in order to accomplish a task. For the second half of the semester, we're still working with Python, obviously, that's in the name of the course, but our approach is going to change. We're going to take more of a data-centered approach. So instead of, say, accomplishing a task, we're going to look more at processing data, which kind of adds another criteria into the grading. Because up to this point, it's just been like, does the program work, or does it not work? And that was kind of the only concern, is did the program accomplish what it was supposed to accomplish? But as we look at data for the last half of the semester, there's another criteria that's going to kind of start creeping in, and that's not only does the program do what it's supposed to do, but how well does it do what it's supposed to do? Is it terribly inefficient, or would there be better ways to do it and stuff? We want to think about how our data gets processed. Once again, it's one of those situations, anything that fits in the time constraints of a classroom, the data we're going to be processing really isn't all that big of a data set. So it's going to go quickly, but there are still plenty of very, very large data sets in the world that we can work with. So the first thing, as we transition into working with data, is we want to keep it around, and not in memory. Because memory is it's a resource that we need a lot of when we're programming, right? We don't want to waste lots of memory just holding the data for our variables. Stick some stuff, some strings and integers and a few variables there at the beginning when our program gets loaded into RAM, and maybe use them once in the program. We don't need them sitting there the whole time. So that's one of the things we want to look at, is as far as efficiency, it's efficiency in terms of RAM. Like, are we sitting there wasting RAM with data we don't need anymore, or data we're not going to need for a long time, or so we don't want to just set up our data, we want to get our data into RAM, processed, and back out of RAM as quickly as we can, or as smoothly as we can. And well, if we're going to hold the data in RAM, we need to hold it somewhere. And there is most of our machines are going to have storage that we can use. And anymore, the storage is mostly going to be solid state drives, which means writing and reading the stuff from long-term storage, the non-volatile storage, is a lot better than it used to be. Back in the days of the spinning disk, like actual hard drives, we had that disk that would spin around, and there was a actual little head, magnetic head, that had to be moved into place. The disk would have to spin to the right spot, and then that little magnetic reed head would have to move in and out and get to the right spot. So that was the biggest time constraint there. Also made a lot of noise. So if you were in like the lab I'm in here, I just zoomed this in, I think y'all have seen the lab before. Been in a room like this with those disk drives constantly spinning, it produced a lot of noise. Solid state drives are a lot faster and quieter. That's one thing. That's the one thing that's always in my mind, is how much quieter computer labs are than what they used to be. But solid state drives are a lot faster. We used to have to do things. Getting the read head into place was our biggest bottleneck. So we wanted really big files. That way we could read the file. We don't have to move that read head into place once, and then we read that whole file and then process the data afterwards. But with solid state drives, it's actually more efficient to have lots of little files and data scattered around. We've talked some about manifest. Python has a number of them. I'm going to step away from Python. Just a quick example. In Java, the programming language that was most popular programming language for many, many years, until computers were fast enough to keep up with the leg that Python brings with it. But with our manifest, there are different ways to do it. When they originally created Java, they created one called ANT, which stood for another neat tool. That was an error when everybody thought of everybody was thinking of what they wanted the anagram to be before they thought of what words were going to describe their technology. It's a strange time for naming things in technology than the technology and everything else. But that was around for a while, and it was kind of a big thing. It was highly organized, put things in lots of different places, different files. But eventually it was replaced, and anymore in Java projects, we basically use two types of build configurations. That's what the manifest is. It's part of the configurations on how to build the software. But for Java, the two ones used anymore are going to be Maven and Gradle. And when you all see take your mobile app development course, you will be working with Gradle some. But those are the complete opposite ends of the spectrum. So Maven has a centralized thing. Basically, it's like the quick summary on it. This isn't an exact description, but the general summary to get the idea of it is Maven would be like one file with 1,000 lines in it. That's all the build information for the software. And at the other end of the spectrum, Gradle, those sort of manifest files, would be more like 1,000 files with one line each. And obviously those designs would be very, very different between the spinning disk drives and a solid state drive, where we just flash the data on and off the solid state drive. 1,000 little files with one line each would really slow down that bottleneck from this physical spinning disk drive versus that's the optimal thing for a solid state drive, and vice versa for the other one. that one file with 1,000 lines would take a noticeably long time to flash out of there. We would notice it being longer than some of our other files. But if that was on a spinning disk drive, our time delay only has to happen once. So that we just go to that one spot and read the whole file in and then deal with it later. Stepping away, because that was an example that popped to mind and something y'all will see in future classes for most of y'all, I think. We will have to take the mobile app development course, or one of the mobile app development course, something in the 260s. There's a couple versions of them. You'll see one of those when you get there. And the general idea of it applies elsewhere too. We know what machine we're on. We would do different things and storing our data. In the previous course, I would have saw just writing sequential text files. And I left my orange notebook at home this morning, but I remember basically what was on there. I can't remember if I had any really nice ways to phrase things that I thought of and put in the notes, but we've seen that before. And so what I wanted to do in class tonight, we talked about it briefly when we needed it the other day as well, is look at some other common other ways we can store our data, the long-term storage, keep stuff around. And not just the storage. So the one I want to start with, it's kind of like long-term storage. It relates to writing files. But there's another issue with software in general. What's a good way to pull this up? I'll go ahead and share my screen and just pull up a Google search for something. I got an idea. The last assignment asked you to do a stripped down thing, kind of along the lines of task management software. Really just a couple classes for that to look at some points. A way to organize the data for task management software, that sort of thing. But if we went and look for project management software, so here we go, right after the ads. The first one after the ads explicitly says best project management software, indicating it's referring to a list of some sorts, right? It's a magazine, so there's probably lots of ads. Okay, yeah, so Gantt Pro, Teamwork, Zoho, Lexis, but there's a bunch of them. There's definitely more than one. I was expecting a 5 or 10 list. The very top option is 55 best to choose from. It's quite a few, right? And then we get to more reasonable size list that we could read through if we weren't getting paid by the hour. 15, top 20. It's quite a few of them. And other software is going to be like that as well, right? Game engines. The long list of game engines. Whoops, I didn't mean to click on that. Oh, Wikipedia just has a big list of them. Start scrolling, scrolling, and scrolling, and scrolling. But the point being, there's lots of them, right? What's another type of one? Oh, our class example. Doing payroll software. Oracle's got some. Top 10 best ones, which again seems to be a list. Yeah, a list of them, but the general point there is pretty much any type of software we would name there's gonna be a bunch of them out there, right? And even if we have some brand new awesome idea, world changing idea, create a piece of software that's unlike anything that's ever been around before, how long is it gonna be before there's another one? Or more, right? Because people are gonna be like, that's a good idea, or other people might see it, especially if it's something that programmers would interact with. They're gonna see it and probably dislike a few points about it, so they're gonna make their own that's like that fixes those points they didn't like about probably your user interface. Uh, that's what people would pass judgments on. We've talked about that before, but there's lots of alternatives of software. So when we write stuff to a file for long-term storage, there's two things, kind of two places we need to take into consideration. Other software, or our word for that, is going to be compatibility. Compatibility with other software. Anybody ever maybe had a piece of software you like to use, something you stumbled across along the way somewhere when you on a random Google search, maybe you updated it to a new computer, when you went to look for that software you liked before and couldn't find it for some reason. Maybe it was too low in the Google search results the second time and you had to download it and try something else. Or maybe they hadn't updated it since the version you had, or moved on to a different project. The next update of it was going to be so significantly different, they counted it as a different piece of software and gave it a different name and stuff. In which case you had to go with another type of software that did the same thing. You might have still had your own files, so you'd really want them to work with that other piece of software. Common things, Word documents, right? Or I should say documents. If we write a document, there's a number of Word document editors we expect that to open with. At the very least, Microsoft Word, Google Docs, LibreOffice. I guess Pages should probably be on that list. A lot of people use that. But there's a number of popular ones. And if we're a decent sized business, there's a good chance that other people that might need to see the Word document we wrote are going to use something different than we did. So we need that compatibility. We needed our software to work with other software. The other thing is for our own software. I don't want to write non-compatibility. Unique. Yeah, I'll just say unique. That's the opposite of compatible. Something that works with our software and only our software. And we would approach these somewhat differently. The one we've seen before, you all would have seen in the SDEV 140 class, and kind of all that's on the homework is reading in the file and then doing stuff with the string. So it really seems more like string-based homework than file work handling sort of homework. But when I looked over it, I was thinking about adding more, and I was like, nah, let's leave an easy assignment on there. And we'll talk about some other points. The sequential text files are kind of unique. We could read those into another program because it's just stored as Unicode, right, with the .txt extension. However, there's that issue y'all might remember that after we write it to the file, when we go to bring that data back, it's important to remember the order we put it in. That's the reason we refer to them as sequential text files instead of just text files, because that order matters. Our program wrote it in a certain order, and we can really only read it back because we know what that order is. So that goes over here on our unique side. Sequential text files. Where we, each data point gets its own line. So for every data point we have in our software, we're going to write it on one line. And then when we need to retrieve that data, we'll just read it back in the same order we wrote it in. Works great if the same software is reading it, is working with it. But if we need it to work with other software, that could become an issue. And this is pretty much all that's on the homework assignment. But the other stuff, all this stuff over here, that's going to go on this side of the board is going to be much more useful for you as far as software development goes. Read back in the same order. So the sequence we write that data in and then read that data in matters, as otherwise our data would end up in the wrong, going to the wrong variables or the wrong list or dictionaries or sets and tuples or some other ones we're going to look at this module. But the order matters. There's a couple others. I'll go ahead and fill out this side first that are unique. Binary files. We can, the text-based stuff, the scripts we're writing, the way we handle our data, all of that is just, that's extra stuff piled on top to make it easier for the human to work with, right? I think everybody's aware of that. The class was talking about all the ones and zeros and how the computer can do math. It's a long section, and at the very end, usually in that class, they briefly mention 2's complement and excess 27. That's what computers actually use. All numbers are stored as 2's complement and excess 27. And that's how all our processors work, but that gets really confusing, so it just gets tacked on at the end. And we just talk about those nice integer formats for most of those explanations in the intro classes. We're still working with binary code. That's what the computer's actually doing. It's either got a number that it can do math with or an encoding scheme. Probably Unicode, but we can have a unique one.
I'm sorry to interrupt. Have you or do you know anything about Dale that he's supposed to be here at 6?
I have not heard from him.
We're all a little worried. We don't know where his supervisor is at either, and we don't even know what to do. He's never late.
Yeah, that's what I was thinking. Dale's never late. He does work during the day. Is there like traffic issues?
Not really. I come all the way from Corden. Is there anybody in the campus that I could talk to, or?
If
Probably I'm so sorry.
if you try the front desk, she might know some numbers get a little clear in here. Somebody else.
Okay, thank you so much.
Yeah.
I know, for us too, I think it's weird because Huey gave us extra credit for being early. But I'll definitely go to the front desk and see.
Yeah.
For the most part, there's a couple missing, but yes.
Well, I can verify that y'all are there if you have to wait too long, but.
Okay,
Yeah,
I'm gonna see if I'll walk up to the front desk and thank you.
Yeah, see if they can get a hold of either Dale or Larry. They might know their numbers. Sorry about that. So where was I? Oh, yes, binary. So the computer's actually working in binary, and then the text-based stuff, the code we write, the data we're working with, putting that in even somewhat human readable form is just to make it easier for us. So obviously that's a good way to store it, but it's unique. It's going to be somewhat based on our own thing. Especially in Python. That one can kind of go either way. If we're talking across the board with software development. With some of our languages, it is just straight up encoding. Python doesn't really play well with other languages, which is the reason I wanted to fill in this side, because that's an important issue. So we also have the binary files. Oh. This is why I like chalk. The dust from chalk gets annoying, but I can tell from across the room when I'm at home, I can tell from across the room how much chalk I have. That marker was just working a moment ago. So instead of writing a human readable text form, we can just keep that stuff right in binary form, throw it to a file, and when we want it back, we'll read it back right back in. So to do that in Python, we do what's called pickle the data. That's a verb that we don't really use anymore. Anymore, we always say serialize. But back in the late 80s, early 90s, when Python was created, pickling the data was a more popular terminology to use when discussing it. So that's what the library we actually use in Python. So I'll go ahead and write that here. Pickle the data and dump it. Then then load the data and unpickle it. There's a popular verb for back in 30 years ago, I guess, because well, y'all know what pickles are, right? You take a cucumber, soak it in vinegar and salt for a long time, and it gets all that really good flavor. All the clean water that the cucumber grew absorbed while it was growing gets replaced with the flavor from the vinegar and salt solution. It's kind of, we think of it like that. Our data is still, we could look at it, if we knew what we were looking at, we could look at it and tell it came from the same thing, but it seems like a completely different product. Right? Pickles hardly seem related to cucumbers, and same thing. When we have the data from our program, if we look at it in the binary form, if we look hard enough, we could tell it's the same thing, but it doesn't really look like it at first glance. That's why that was a popular verb 30 years ago, but serialize is a more common way to say that these days. Serialize. Pickle is an oververb. Pickle is an old verb. I think I ran out of room. There was one more I wanted to put on that side. A very popular one is relational databases. Does some of y'all in here have you had the DBMS 110 class, or any of the ones that follow that up? The relational database where we can use structured query language, SQL stuff, is built into Python. In our default installation of Python, we do have a library called sqlite. Which is a relational database. I guess that's enough to write down here. Those are common things. I'll draw a picture, just in case anybody hasn't really seen the picture. You've probably heard the terms before. So one way we can store our data is in tables with nice rows and columns, right? And normally if we would do something like that, we'd want some labels. So typically we use column labels, and all of our data is structured. And structured means we know the same things about it. For example, if we had just some data about people, right? Maybe person one, we know their name and the town they live in, and the age there. So name, age, and town. And person two, we know their name, we know what their favorite food is, and we know what type of car they drive. So in that case, we know different types of data about each one of our objects that we're working with. That would be unstructured data, because we would need 5 fields, and in both of those cases, both of the objects that we're working with would be missing 2 data fields. So that's called unstructured data. We'll talk about that here in a second. So tables are more for structured data. And we know the same thing about every single element we're studying, like the name, age, town, favorite food, and we can fill in every cell on that table. And each row gets filled in fully. Then we might have another table though. Again with headers. And we can link things up. So maybe this row and this row are actually the same data. We can use that to form a connection. A relationship between our tables. And it's kind of like a shortcut for the computer to travel around between data points. So then instead of having to read in the whole data, all of our data like we would in a sequential text file or a binary file, if we know maybe this piece of data right here, if we know that one and we're looking for some sort of condition, we can follow those relationships around. That data is related to the next column over. And then that column is related to this other table. We can come over here and maybe find this piece of data just from the relationships and not have to worry about all the other data in the table. So it's very, very fast and a highly organized, efficient way to store our data. Because we don't need all of it. With both of these, we need the whole file every time. If we serialize or pickle our data and write that to a file in binary format, the only way we're getting anything back out of it is if we bring that whole file back in. A sequential text file, the order matters, so we have to write all of our data to that file in a certain order. And the only way we could abbreviate that is if we stop reading when we find the data point we want. But if the data point which we want is the very last line, we have to read all of it. So we need all of our data, or up to all of our data in these two. But with relational databases, we can jump right from point to point. And SQLite is available in most of our languages. It comes installed in Python and most of the other languages that you would hear about these days. Some of the old ones, they're just kind of still hanging around. You might not have SQLite installed. Anything Google does, that is a requirement they'll put on things. So if you're gonna, if you want Google to use your stuff, it has to be compatible with SQLite. But I'm just gonna do a quick search for it. So SQL, like SQL for structured query language, but then Lite. And yeah, it's for structured data because then we don't need our data. We can deal with the relation. We can work with the relationships between things. So this is SQLite. Small, fast, self-contained, highly reliable, fully featured SQL database. So everything we would want from a relational database. I'll do the picture. I turn my camera back. Notice the camera got moved over and I've got to bring it back. So all the stuff we would want from a relational database, and it's a programming library. So just like our other modules, packages, libraries, different terms for the same thing, essentially the pre-written code that we can import. Yeah, in Python our keywords import, but other languages we might say include or use. Whatever our keyword is to bring that other pre-written code in, we can bring in SQLite. It's built into the default installation of Python. And then the second paragraph down here, so it has everything we want, but it's stable, cross-platform, backwards compatibility, and everybody that works on that project has to sign the pledge agreeing to keep it that way till 2050. And that's not where they're going to cut it off. 2050 is when they're going to evaluate if they want to go further. So it's going to be around for quite some time in the future, has all the features we want. So we're working with a relational database. The trade-off for all that is we have to embed SQL code into whatever other programming language we're working with, which often happens anyway as we get into bigger and bigger projects. But it's a small one. It creates a local relational database that we can just throw in some SQL code as a string. It's not so bad in Python. In some of our languages, like if you're doing it in C, where you have the semicolons at the end of the line, means end of instruction. So every line has to end with a semicolon. When you write a SQL statement, you end up with two semicolons because the SQL statements have to end in semicolons. And then your C instruction has to end in a semicolon. So they're along with other symbols for those who have seen SQL before. So there's some little tedious parts in there, but it is a really great way to store our data, set it up locally. But for anybody that's worked with SQL statements, you also know you kind of have to know the database you're working with too, right? You have to know how that database is set up and configured, which is why it goes on the unique side, not on the compatible side. Because if we tried to transfer that database to another program, we would need the entire schema and have to rewrite the whole database for the other program. So technically it's compatible, but feasibly it's not. So it's more for a unique thing. So we have some unique ways to store data. But the one I wanted to, ones I want to look at first here are for going the other way, for compatibility with other software. Basically transferring our data. That'd be a good word for it. If you have a piece of software that you really like, you've been working on something, or maybe some people you know had a piece of software they really like. Do you want to replace that? So you've been working on something and then we see if it worked. They like your ideas, they know you're still debugging it. They'd like to see some stuff. So we need a way to get the data from your program over to their program. Something standardized, basically. Standard ways to transfer data. And there are three big ones that are essentially special types of sequential text files that are pretty much standard for transferring data. The first one is a CSV file. It's comma separated values. Oops. Comma separated values. We take all our data points, all the things that are connected, so like an entire list worth of stuff. Yeah, actually, the CSV library in Python works with lists. We take a list, say, right, CSV.write it, and that list, it puts a comma between each one, and or we can change the delimiter. We can choose whatever delimiter is. The default is commas. Organizes things. CSV files grew into spreadsheets, if that gives you an idea of the organization. Once graphics were included, the CSV file, comma separated, really means that there's something delimiting each data point. So whenever that turned into graphics for graphical user interfaces, that became a little box for each individual cell. Because yes, we can put formulas in there and stuff, and we can calculate it. So CSV files are big. From CSV files are what grew into spreadsheets. A whole lot of growing has happened since then, so we definitely don't consider them the same thing anymore. But usually, the default way to open those is with a whatever spreadsheet software you have locally. And there's a library called CSV built into every installation of Python because that compatibility issue is important. And Python doesn't really play well with others. We need some easy ways to get the data from our Python software to another piece of software that may or may not have been written in Python. The next one is JSON. I'm pretty sure the notes I had at home had a few more points about this, a few more points about these things, but at least the basic idea here. So I haven't talked about dictionaries yet. We're gonna talk about dictionaries soon. What's the quick summary of it? We saw a list where we put a whole bunch of data into one container, essentially, and then each one of those is indexable. Right? There's a unique way to identify it. The default on the list is just going to be those order, the numerical order, starting at 0 and going up to however many things there are. We can ask for those indices one by one. But integers aren't the only way we have to index things. We can also use strings, which is much more useful. Much more useful, because when we do it that way, well, those numerical indices that are put on the list, for us, either the Python programming language does that. If we're working in C#, the C# compiler does that. And whatever language we're working in, that handles the numerical indices, which means it's unique to our program. Sometimes we can move to other programs written in the same language, but we have to send the entire list. We can't separate parts of the list. We have to send the entire list to get that numerical indexing to repeat in another software in the same program. But that's not really compatible. However, if instead of letting the programming language number those values itself, if we use strings and just assign each one of those data points or values that we're storing to a string of characters, the normal human language-based representative language, sound stuff, whatever you want to say, call a string. Also, words we can say that. But if we use a string instead of a number, we have to assign that ourselves. So there's not a internal algorithm doing that based off other stuff that's going on in our program. That is something we explicitly did. So it's not the case in Python, but in a lot of our other languages, when we do that, has different names in some, you might call it maps, associative arrays. Python, we call them dictionaries. We're going to talk about those next Monday. Just if the schedule holds together. But lots and lots of different names for them, depending on what language we're working in. But the idea is still the same. It's kind of like a list or an array, only instead of the numerical indexing, we use strings to index the stuff. So they come in pairs, the value we want to store and the key that indexes it. So in Python, we call that a dictionary. In JavaScript, one of the languages in our world that is officially labeled as a standard for something somewhere. That one in JavaScript is called JSON, JavaScript Object Notation. If you just look at them happening, if you just look at the code, it would look exactly like a Python dictionary, because I think everybody has seen them before. We talked about them a little. It would look exactly like a Python dictionary until you got up to how we pass functions between them, which JavaScript does much, much better. But that has kind of become the standard format for transferring unstructured data. Key value pairs. Key value pair data structure. And most of our programming languages can work with it. So software written in most of our programming languages can work with it. And this is the preferable one for unstructured data. Or unstructured. CSV files are preferable for structured data. And the reason being that if you think about a spreadsheet, I mentioned CSV files were the ones that grew into spreadsheets once graphics were involved. All those little cells make it look an awful lot like a table, especially if we put some headers at the top. So I'll put that here, especially with headers. If we go ahead and put the first row of our CSV file as a row of labels, then that looks exactly like a table. So obviously there's a much better for structured data. JSON is better for unstructured data. So structured is when we know the same stuff about every one of our data objects. I'll say rows. So think about rows in the table. If every field in that row is going to be full every time, that's structured data. But if we end up with lots and lots and lots of fields because we know different things about everything, and almost all of our rows have lots of empty fields because we just knew the data is almost randomized what we actually know. That's unstructured data. JSON has some advantages to that. And the other of the three big standards for transferring data between different pieces of software, across networks, all of that stuff is going to be XML, extensible markup language. Let's see, that's going to be tag based markup language. I know several people in this course have seen the had the HTML class. We just finished that a couple weeks ago. Saw some great final projects from you all. So I know you're familiar with the markup language, or tag, the tag-based markup languages. If you haven't seen, anybody hasn't seen those, the basic idea is we include some extra stuff that makes it better for the machine. That's a place up there on the board. So for example, in Python, one of the things that makes Python so nice is we pushed a lot of the work onto the machine. It's less efficient for the machine, but it's a lot easier for the human, right? So it seems like we can do more with less work because the machine's doing all that work without complaining. But that goes the other way too. If more work gets pushed onto the human, then the machine has less to do, so the machine can actually run faster. And one of the things we can do, maybe we have some words we want to store. I'm just going to write data point. That's a good string. We have some data point we want to store. And we can pass some other work onto the human, which really we have code write this part for us. So humans don't actually do this work. But we add some tag, some extra information. Using angle brackets, which is the standard symbol for type. If anybody's worked with any strictly type languages, you would have encountered generics at some point, where you use angle brackets to say what type of data you have. Instead of data point, I'm going to write Chris, first name. I wrote my first name. So we could say what type of data we have. So explicitly, well, obviously it's text-based data, a string, but we can give that a more unique identifier. Say name, and then a forward slash and name to say where it ends. So a little bit more work for a human, but it's really, really good for a CPU because every piece of data then includes, well, the data itself, where it starts at, and where it stops at. So we don't have to worry about size or anything. There's explicitly a mark that says the data starts here, and then the data itself, and then a mark that says the data ends here. And we can include some metadata. I didn't leave much room here, but we call them attributes. So I don't know, I'll add an age attribute to go with that name. So include every piece of data includes the data itself, where it starts, where it stops, and potentially some metadata about it. So in general, a really good form for computers to work with. And really easy for programmers to work with too, because if you have a whole bunch of these things in a sequential text file, a bunch of different tags, maybe some of them say name, some of them say city, some of them say hair color, some of them say shoe size, and a whole bunch of stuff like that. In a sequential text file, that's going to be really, really easy to write a selection structure for, right? Write a big if else thing and uniquely identify. Everybody in here knows how to split up a string, right? If you had a string that looked like that, it shouldn't be any trouble at all to split that up and have those tags uniquely identified to go right into selection structures and make things work. So markup languages are good for a machine and a human with just a little bit of extra work. And if we have the computer write those tags for us, it's really not much extra work at all. So tag-based markup language works good for structured and unstructured data. For structured and unstructured. About equivalent both ways. There's not really one advantage over the other. And that's not a restriction. Obviously, we could do structured data in JSON and unstructured data in CSV and not run into any problems at all, except empty spots. That's the problem with unstructured data in the table, is we have all those empty spots that are wasting space. So it's not a restriction. They're just a little bit better. JSON's a little bit better for unstructured data. And CSVs are a little bit better for structured data. And XML is about equivalent for either one. So those are kind of our main ways to transfer data. Pretty much just standard. If you're going to work with software, that's what you expect to see. I want to ask, how many of you all heard those words before you ever started into programming at all? Encountered CSV or JSON or XML somewhere. Something that you may have encountered just because it's so common for that. It's basically our standards for transferring data. Screen up in my over in the chat room. Yeah, it's everywhere. It's become the standard. So yeah, I got confirmation on that question. So before even starting to learn about programming, these three are so common that you would have heard of at least one of them. You may not have heard CSV files because that doesn't exactly flow off the tongue very well, but you would have surely heard of spreadsheets. And CSV files grew into spreadsheets once we adapted the graphics, and then instead of using a comma or a space or a tab or an asterisk, we choose what the delimiter is, any symbol we want. Instead of using a delimiter, we just drew a box around every piece of data. It's still separated it the same way as a CSV file. So you would have seen those. And all three of them, the default installation of Python has a library to work with all three of those ready to go. So need some data. Guess I'll go ahead and jump over to example now. Hopefully this will go quick. Yeah, I kind of already talked about everything, so it's just a matter of using this stuff. We need some data to work with, so I'm going to start with that and make a little object to organize our data. So a class, I'll call it person. I'm quite sure everybody in here has seen my default generic classroom data example. Name, age, and town, that covers a few things. So we'll define a constructor, self, name, age, town, and set it up so we can refer to that. So like self.name is the name we pass in, and all of that stuff we've seen before. The age that belongs to this object is the one we pass into the constructor. Self.town is the town. Or something. I'll just make a string. That's the only part I need for the example. So
We'll see you next week. But I don't think it was making people
yeah, I'll just do self.name. I'm gonna write self.name as a person, but that's the only part I actually wanted there was the data points, just to make it a little bit cleaner. Because we want to store data, we want to organize it into these formats. So we need more than just an Well, we need several data points about everything we're considering. Kind of like the idea of the person object here. So best thing to do is to make our own data type that includes all those things. And then it's nice and organized. So now I'll go save this somewhere. Documents, delete. Oh, good stuff still here. I'll call this file transferred. I'll make a folder called transfer data to just cover these three big ones. What is this? This is the person class. Person.py. No surprises there. Y'all have seen my generic classroom data examples, so you probably could have already guessed what that one was going to do. I just did the string method on there to have something. All I actually went there is the data points. But we're going to need that. So import person, and then make a list of them. People, it's going to be a list. Person, I'm just going to make up some names. Charlie, age 22, from Charlestown. Space 4 is probably good. Although that's looking like a mess. I'll split those lines up to make it a little bit cleaner to read. Oh, whoops. Okay. I should slow down and just kind of see how much gets out. I started trying to go really quick, thinking, oh, maybe I can get this knocked out really, really quick, but I shouldn't do that. We've got time. We've got this is 16-week long class, so we'll just get started in this, and if it trails over to the other day, over into Wednesday, Tuesday, we'll just pick up there. So that gets our data. It's in a more realistic situation that wasn't potentially stripped down to the bare minimum we need. There'd be a bunch of methods and stuff, and we do have all kinds of things we're doing with this data, right? Processing it, moving it back and forth, doing stuff, but we're ready to store it. And when we just want to store it, we're doing very common things. We want it to be compatible with other stuff. We're going to be able to use it in other software too. We're going to be able to send it to the central office for the company up in New York and load it into the main database there. Or we want to broadcast it out to a bunch of other people because we're done processing it or something. But there's something we want to do with it that it needs to go somewhere, and we don't know what the other software that's going to run it is. We don't know what's going to happen after we transfer it. We're just going to store it for ourselves and transfer it across the network. So I'll start with the CSV. That's a which I'm just starting with that one because it's on the top of the list here. I guess alphabetical order. So every installation of Python has this library. That's really small, isn't it? Okay, hopefully that's a little bit better to see. White space. Scroll. That's some white space there. So we have our data, and then Python includes this library CSV. And well, a CSV file is a special type of sequential text file. Connected data, similar data, goes in the same row and gets delimited by commas as opposed to its own line, like I marked up here for sequential text file. So we can just do that directly. I will open a file. I believe our textbook does this a little bit different. They use the open method and then assign that to a reference value. So like file handler equals open and all that stuff. I always go with the with notation. It just feels more like the standard Python syntax to me. They work about the same. The biggest difference is the with notation will automatically close it and has a little bit of error handling in the background for some very common issues. So we need to open a file. I don't know, data file 1. And we'll give it the CSV extension because extensions are arbitrary. We could call our Python script not HTML. And if we explicitly told the computer to run it with Python interpreter, that Python code would run, no matter what the extension is. The thing that would happen there is the text editor wouldn't change the Python code to the right color if we coded a different extension. So extensions are arbitrary. We can make those up, but there are some, especially on the common ones, it's a good idea to stick with what it normally is so people will recognize it. Or in particular, so that other software will recognize it. Because that's what we're looking for here, being compatible. Our program having compatibility with other programs. So we're going to write a file as, I'll say CSV handler. We've talked about file handlers briefly, and you would have seen that in a previous class. There's a very slight distinction, which I was hoping to get to Wednesday, but since it's already 10 after 7, we might not get to that distinction between file handlers and actual files, where we import the OS library and start working with files themselves instead of the file handlers. But that's coming up very, very soon. But there's a slight distinction. This is the thing we can see our file, and in particular, read what's on the file or write stuff to the file. Once we have a handler, we can make a CSV writer object. So that CSV library has an object called writer, and you can see there on the predictive text what we need. What file are we going to? And some other parameters. Yeah, I guess there's not much there. We can change the delimiter, and there's a whole bunch of options. Okay. The bare minimum, most of them are optional. The only one we have to have there is say what the handler is. So we'll open that CSV file. And now we can just loop through our list of people. Oops. 4P in people. Writer, right row. Notice we have right row and right rows. So if we have nested lists, right, a list holding other lists, multi-dimensional list, we can write multiple rows of a CSV file at once. But these generally want a CSV file. So, or sorry, these want a list because it corresponds directly to that iterable data in our language. Well, both of these do. These two both correspond directly to iterable data of some sorts. So we want to work with lists in them. And then I'll just call up those points I want: the name, the age, and the town from each one. Oh, whoops, I thought that had already been saved. It's a good name for this. Or compatible. That's a good name. So the things we need to be compatible with other pieces of software. It's kind of an important issue. So I wanted to make sure and cover it somewhere, and our book doesn't really talk about it. They just sort of a bare minimum of file writing. But that'll write to our file. I'll go ahead and write it first. So if we run this, what did I get in that part? Oh, whoops. That should be right row. I'm pretty sure I said that. I think we paused and talked about it, but apparently didn't type the words I was talking about. There we go, ran without errors. So we go over here and check our folder. Oh, actually, I have a file explorer here in Spider. So we go over to files. Here in the folder we're working in, see data1.csv, and you'll notice the little icon it gave it. Looks like a grid or a table. We open it. Oh yeah, I forgot Spider does this. Spider doesn't like the carriage return. Doesn't like formal line ends. It does a carriage return, new line. Probably seen before. We usually just use new line /n. Because both terms go back to the days of typewriters. You almost seen typewriters in like old movies or something. If you just spin the wheel, that's a new line. So if you go over to the end of the page and then spin the wheel, you're still typing at the end of the page. A carriage return spins the wheel and goes back to the beginning of the page. So it spins and goes back. It usually doesn't make much of a difference. Sometimes it does, but like in this text file, if we go to the new line without going back to the beginning of the line, there's nothing in the next line. If we were on line 7 and hit new line, go to the next one, there's nothing there. So the only spot we can go to is the beginning. That's not always the case, but that's the difference between the \r and \n. Yeah, so that's what our file looks like. Oh, whoops, I meant to change that data. Sally 38 from Salem. Alan, who's 16, Albany. And Jeff, who's 22 from Jersey. There we go. That way there's different data on there. So we ran it without errors. If we go look at that file, you'll see the icon by default, it wants to open with the spreadsheet, which I don't think I have any spreadsheet software installed, so it's probably going to try to install Excel. Oh, I guess I do have it. Oh, I don't have a license. I have Excel. It's not allowed to use Excel. But you can see there, every data point got its own particular line. And that's sort of a standard thing. If you go look around at other software, like here in Excel, if you go over to the data table, there's some important things, get external data, which are grayed out here. But one of the ones from other sources is going to be these 3, especially CSV. That kind of tops the list. That's the one Excel's made to go with. But if you look at other start looking around at other software and how it imports data, you'll see CSV files show up all over the place, along with the other ones we have there. And we can read it back in the same way. It's built into the library, so we can just open the file back up. I forgot what I called it. data file 1.csv. Only this time open it in read mode. I'll give it the same name again, CSV handler. And you probably guessed probably could have guessed very quickly what our main object for reading a CSV file is, especially having seen what the main object for writing a CSV file is. And we go to that library and we have a reader object. And the only required parameter is the handler. I'll do this first. So for row and reader, I'll just print it out. There we go. So you can see that extra line kind of caused a problem. So I know at least whenever I'm doing CSV files, I like to check and see if that's empty. So if the length of that row is not 0, then we know there's something in it. It's not one of the things, the after effects of the library, including both the carriage return and the line feed. So that should clean up those empty ones. Clear that, run that. There we go. So we sent out our data, got our data right back in. Notice it's not in the form we sent it in. It's just the data. It's been stripped out of the object, but we could load that back into our objects very easily. That's not much of a problem at all. And like I just mentioned, that if you start looking around at different software, you'll see all over the place wherever they have an import button, you'll see CSV files are quite often an option. Another thing that I really like about CSV files, something that I have found that can be incredibly useful for, is a CSV file is actually going to be very similar to a binary file. The way it's laid out, that extra space and everything there that we just saw, that almost looks like a problem, that shows up in binary files. And things are organized kind of that same way. They're delimited. Obviously, it's a different, a special kind of delimiter, and we probably wouldn't be able to spot it if we're just looking at a big file full of binary code. But they're delimited in a similar way. So they have a very similar format. So whenever I want a software to work with a binary file, and while debugging it, I like to have a CSV file as well, because it's very similar. So then when debugging the software, there's a human readable version that's kind of laid out essentially the same way as the binary file, which we'll see binary files in a couple of days. So that's another very, very useful version. Useful place for CSV files is they're very similar to our binary files. So when you're debugging stuff, you can get an idea of how the data is laid out in the binary file, and also sometimes track stuff down. If you open it, if your text editor has tools or plugins to automatically change encoding schemes, you can open the binary file and change different encodings and track down bits of the data that way. They can be helpful for that, or just to see it in general. Yeah, that's basically what I had for the CSV file. JSON's about the same thing. Whoops. So our library is just, the built-in one is just called JSON. And then we can just open a file and write it. With open, I'll give them the same name, data file 1.csv. JSON this time. Again, that's a common thing. So a lot of our software, such as a text editor, would recognize it and change colors appropriately for JSON object. I'm gonna write some data as JSON handler. And here, we use a regular write statement like we would, the JSON object returns a string. So we would use the regular text file writing handler write method to just dump our JSON file. And that is our word. So, so JSON handler, it's a file handler, so it has a read and a write method. So we just use the write method from that JSON package, called it these two. We have dump and dumps. So anybody have a guess on which one we would need? We want to do a JSON dump or have JSON dumps this data. I just wanted you to think about that for a second. It's the plural one. I don't know who wrote this library, but I always have to pause and think about that, and it's kind of hard to. I don't know who wrote the library. Those words are way too close to each other. They do different things. On the CSV library, write row and write rows do the same thing. It's just a plural version of it. But JSON.dump and JSON.dumps with an S are quite different. We want the one with the S. And it needs to be a key value pair. That's the power of those data structures. They can leave and work with other software. And strings paired with the data we actually want to store is a combination of primitive elements that will work in any programming language. So the form that can leave our program and run in another program is the power of it. So we need to set up the key value pairs. So the name is going to be, oh, whoops. I'm going to do that same loop again for P and people. Hopefully that jumping aside didn't get too confusing, and hopefully maybe even cleared it up a little as to why we weren't looping through the data already. I just forgot to type that, sorry. So we'll set our the key and then the value we want to for it, and then just a comma to separate them. And we're going to talk about dictionaries in more detail soon. It's essentially like this, but we're actually writing a JSON object, which I guess I'll, oops, p.h. And town is going to be p.town. As always, I like to leave the error messages in there so we can see them. It didn't give me the error message. Okay. Sometimes that in the past, I've had trouble with the JSON library trying to pass an integer into it. It wants it as a string, but it didn't know the error message, so I guess it's okay there. I was expecting an error message there, so if you see one, it's just simple casting. Maybe it's 310, because that's always happened to me in the past before. Is if I tried to pass in an integer I got a type error and said that an integer is not serializable to a text file. But it seemed to work fine, so I'm not gonna question it. As you can see, we have this file over here. There's no icon, it doesn't know what to open it with. Spider knows what it is. Here, you'll notice the little picture, it definitely gave an icon that matches what the JSON matches, seems to fit with JSON, same way that grid fit with the CSV stuff. So we open it here in Spider. You can see we get some nice color changing too. So very nice color changing, because notice about those strings. It can tell some of those strings are keys and some of them are values. They don't change to the same color. So, yeah, highlighting the importance of using the correct extension there. I'm going to add a new line at the end of that. All right, we'll dump that plus a line food. There we go. Makes it a little more readable, but that is sort of the standard. That is one of the most popular ways to transfer that. JSON and XML are probably a little more popular than CSV for amongst programmers, but CSV would be more popular overall because it relates to spreadsheets amongst people that aren't programmers. So you want to keep things in mind, like is your not just is your data structured or unstructured, but who is it compatible with? Who's going to be using that? Who's going to be using it on the other side? Is it a normal non-computer person that's going to freak out when they see those curly braces and colons and all that weird stuff in there? Or is it somebody that's going to know exactly what a JSON file is and look at something like this and start to wonder why there's line breaks? Like, why'd they put a line feed in the JSON file? That doesn't make any sense. The things like that. Who's it going to be used for? This is structured data, so JSON is better for unstructured data, but obviously it has no trouble handling structured data. And same thing when we read it back in. We'll just open up a file handler. Add a file 1.json. Only for reading. As JSON handler again. And well, it's really a special type of sequential text file. So we'll treat it just like we would when we read files anytime in Python. And a file is an iterable object, so it can feed right into a list comprehension or a generator or a for loop itself. So for line in that file handler. I'll just print it. Print JSON dot loads. And once again, there is a load and a loads that don't do the same thing. It seems like loads should just do more, like be able to pass in multiple dictionaries at once or load in multiple dictionaries at once, but that's not the case. So if we're working with a sequential text file, maybe that's what it is. Maybe the S stands for sequential. It's not loads plural, it's load S. If you're working with a sequential text file, you need the ones with the S on it. Which I'm guessing you all will probably do the same thing I do, and it will be long enough between doing this that you might not remember that you want the ones with the S for the sequential text file. So the thing to remember is that the dump and dumps or load and loads on JSON The ones with or without the S is not plural. They do different things. So you can just maybe try them both and see which one gives you an error message for what you're doing. I'll do line dot strip. And the strip is just because we put the new line in there. Don't need necessarily need to print that. So you can see I brought it back in as a string. Looks like a dictionary now, as opposed to a list. Is well, JSON's type of dictionary, so I have to bring it back in that way, but it's in a format that we could immediately convert to a Python dictionary that way. So that's two of the three. XML is really easy. We'll get that. We'll look at that one on Wednesday. And pull up my example from preparing for class. I left my yellow notes at home, the paper notes, but the example is just on my drive, Google Drive, so I can grab that real quick. And I was hoping to get through this evening, but we can at least quickly look at it. Yeah, so you can see there's not much more for the XML. We need the XML library has a whole lot more stuff. So we have to bring in sub packages. Remember, whenever we see imports like that, that's actually a file path. So those dots that we put in Python would be slashes as far as we normally type file paths. So the XML folder / E3 folder / element tree folder, bring in everything from that package. All the Python scripts in that package, and then we'll use the objects out of that. So a little bit more than the other ones like there, but here we create an element. So when we do that, that adds the opening and closing tags. And then we can create a sub element of that root, give it a name, that'll write the tag, and then a dot text field when we actually want to put the string we want to put in there. And there's none of that example there. The attributes, which are written on the board, for those who have seen markup languages before, it's on the other side of the board. I don't think it's on the camera anymore. The attributes are passed in as a dictionary and read back as a dictionary. So you can see we don't have to type all those tags. We just loop through and say what tags we're going to have, connect them to a root, and then we build use that root to grow a tree. That seems more fitting than build a tree. And then we can just write that tree to a file all at once, and that tree has its own right thing. We're going to look at this Wednesday. I just want to do a preview that way, at least talk about it while it's on the board, since it does go with these three, and we'll work through this example, and I think I'll add in some attributes because I don't know why I left them off here. But notice that it has to be right binary, is to make sure it's fully compatible with everything. Python strings aren't Unicode. Most everywhere else in the standard encoding scheme across the world for strings, human string language, is Unicode, but Python doesn't use Unicode. We talked about that. If you want to turn a Python string into Unicode, you write a B before it. I know we've seen the F in front. I know we've seen the format. So like format this string. It's formatted. Well, not really in that case. We can also put a B out front. And when we put a B out front, that converts it to binary. That converts it to Unicode. Every character is 16 bits long. The first 256 of them are ASCII code, UTF-8 encoding.
If we want that, we just have to put a P out front. So to be compatible with other things, XML, the XML library wants things converted to Unicode. The same stuff everything else uses. And then we read it back in the same way. And when we read it in, those tags count as elements in a two-dimensional array or three-dimensional array, or however deep our nesting of elements goes. Hopefully some of y'all know what those words mean as far as markup languages go. But when we nest, the child objects are nested in the parent objects. They're not separate. We identify the children in markup languages by nesting them inside of the parent. So for every level of nesting is another dimension to a list when we read the tree back in. But we're going to look at that in detail soon. I just wanted to at least quickly glance over the couple lines it takes to create an XML tree and write it to a file and read it back. And we'll look at that in detail on Wednesday. And then add some other stuff in mind. So that means the OS library will probably get pushed back to Monday, to Tuesday. I keep saying Wednesday. We'll look at that on Thursday. No, wait. Sorry, I'm very confused by days. What is today? Today is Thursday. Okay, sorry, I had to pause and take it through. Coming back from spring break on a Wednesday threw me off. So today is Thursday. Obviously about out of time tonight. We got plenty of time in this last 16 weeks. So when we come back on Tuesday, we will look at the XML thing and some other stuff, and then the XML stuff, and then we've already seen that. So at least those two binary files and relational databases, the ones that are built into the Python language, and then try to get into the OS library so that we can work with files, like move folders around, copy and paste files from one folder to another, all that sort of stuff. Actually work with the files, not read and write the files. That distinction between files and file handlers that I've mentioned a couple times. So we'll do that on Tuesday. And then on Thursday, we should get into the dictionaries and sets and tuples and being some details about collections. So that's the plan for the next few days. Hopefully that makes sense. This one was not included in our book, so I'm going to upload it to GitHub right now. Y'all have the link to the GitHub if you want to look at that as an example. The internet's not, there's no shortage of examples on the internet and stuff for them, but especially with the XML one, some of the examples make it really, really messy. And remember, check the official documentation first on them, but that can be an important issue as far as software development, because we need our data to be compatible with other software, not just our own software. It's an important thing, right? We live in a large interconnected world, so we might need to send our data somewhere else. And those are the 3 standards for doing that. All built right into the Python language. So very, very easy to do. Does anybody have any questions about that? Okay, I assume the silence means no questions. And I had some lecture notes that I left at home. So I think I might have had some really good wording on a couple of those points in the notes I left at home. But if there was, I'll bring them up on the Thursday. Otherwise, so you had a question about the assignment, Mark? Oh, there's a question here. On the latest assignment? Oh, so let me pull this up. to refer to that. So on that assignment. Yeah, it was my original thought on that, as I pull it, as I get close now, was to use list comprehensions to filter down the list you want automatically. But then I thought that might be kind of confusing. So what I originally thought is after you get so you have the task and resource classes filled out, and then when you get to your test case, you would have a list of resources. So like R1, R2, however many there are, maybe I should have P's there. Because I said programmers and computers, right, for this project, for the test project. So you have programmer 1, programmer 2, and dot, 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 however many programmers there are. Then you have computer 1, computer 2, and however many there are there. Filled up as a list is just what you have available. So the number of resources. So my initial thought, and why that picture says list comprehension, is that you would look at that list. So you have, oops, don't know why the pen kept drawing there. So that was supposed to be an X. The pen didn't lift up for some reason. X for X. It's really hard to write with a pen, so I'm going to point at that. Hopefully that makes sense. So for list comprehension, X for X in that, and then a filter to see what you needed for a particular task. So like if dot, dot, dot. And then that filter part was what was going to get I realized might get a little complicated. So I was thinking things like counting. So like for X and enumerate all available resources, grab programmers until you have 3 programmers for a really big task, or grab 1 programmer and 2 computers and filter the things down that way. That was my initial thought, but that might be a little complicated, is what I realized. When I thought about it the next day, I was like, that might be a little complicated for the very first assignment of trying to figure out that. So does that make sense, Mark? We have the list of all our resources that is manually put together in the actual the test software. So our task object would have a comprehension that looks at that list and like counts out the programmers. So a task is really big, it counts 4 programmers and 3 computers. Or if a task is really small, 1 programmer with 2 computers, or maybe 3 computers, there's a lot of testing that needs done or something. Oh, and then that, yes, that's how this list gets filled up. So that's how, and then that list comprehension is what fills up this list right here. So it does add the resources. And then over here, when the resources have to be created first, right? And we hire a bunch of employees, then we start putting the tasks they need to do together. So over here, instead of a list to fill up, the job that sticks around, that one's just a generator, that one's dynamic. It changes as they have more and more lists. That was my original thought, but then I realized that would be a little complicated. But does the logic there make sense? Have a list, grab all this stuff, so. For example, like in my backpack, you walk over to my backpack and grab everything that's a folder out of it. It's like, okay, I need a couple folders. Start grabbing things, and there's like chargers and notebooks and pens and stuff, but I just want to sort through and find the stuff that's only a folder. So doing that with the resources. And then that is how you would automate filling up that list. It doesn't have to be everything. It was supposed to be filtered down. So, yeah, that's why I realized when I thought it was going to be too hard. So instead of grabbing everything, I wanted to do the if section at the end. Yeah. So everything of the people task, or maybe not everything from the people task, maybe half of the things on the people class. That sort of stuff. So it was going to be a complicated filter. So instead of doing that, you can just use it as an add. So instead of doing all that, just use that, assign resources to add elements in there one at a time. So like pass in a resource and append it to the list. That will probably be a lot easier. I think I got carried away with my thoughts because this filter would get really complicated at times. It's not too bad. Let me jump over to here and kind of draw something. I think I can use this Python list. Oh, you can go ahead and do that. Feel free to go ahead and fill it out manually because when I came back the next day, I thought that's going to be kind of complicated. So like here, a simple one, X, make a list comprehension that's X for X in people. We're going to enumerate people. Again, what I second. If I is less than 3. Something more like that. So I don't want all the people in the list above O. Where'd the rest of the list go? Let me type that again. So I just want 2 people from that list of 4. So I'll say P for P and I in people, but I want to enumerate that. Enumerate people, and if I is less than 3, then I'll print that. I might have got I and P backwards there. Let's see. Oh yeah, I did. For I and P. There we go. So you'll see I only got, I got 3 of them. That's right. Enumerate starts at 1. It gives length, not index. There we go. So that only grabbed the first 2 objects up there. I've got enumerate counts the length of something. So that's just how many it is. And we'll put that in a place called I and count up to 2 of them. But I don't think we've seen anything even close to that this semester, have we? That's what I was thinking of when I wrote that assignment. So it's probably a little complicated. I was thinking there was still some filtering. And p dot name equals Sally. So more complicated filtering like that. Or doesn't it like that? Let's just say there's an error. Oh. Okay. Oops. I think I'm making silly typos now. It's getting late in the evening. There we go. You can see that is enough of a filter to grab only one particular person from there. Anything on the index less than 2 with the name of Sally, which there's only 1 on there, I guess. That one's kind of a trivial case, but that's the sort of thing I was thinking of when I wrote that assignment. Maybe not necessarily the enumerate method, but something to filter down the number of people or machines, people or tools you would need to do that. But I did realize that's going to be kind of complicated, so feel free to make your assign method something like this. Assign resource, as in a resource, and then I don't know, the list dot append resource. That will be fine for it. And then just use either a list comprehension or a generator once you get the resources assigned to figure out what they are. Does that make sense, Mark? So the last thing I see in the chat room was saying it looks like it said you were not doing that, but yes, that will be fine to go ahead and just manually do it, because I realized pretty quick that's probably kind of complicated, but that sort of filter, that if section at the end filters down our data, and we can put together some messy looking things there, so that in one line of code we create a new list that's already filtered down and has only the parts we need and a whole lot of other stuff. But it might be a little bit complicated for a first example there. Whoops. Oh, there's a print line. There's those 2 lines I just copied. There's also a print. Somehow that didn't get copied. If you want to try to do the more complicated filtering, some people like a challenge. It's by working through the hard things that we get better, right? So we don't get better by doing easy stuff all the time. This is kind of what I was thinking, and I was like, when I woke up the next day after writing that assignment, posted on the I thought, well, that's probably way too hard for right now. That's going to be way too complicated and just confuse everybody. But that's what I had in mind. That will work. Yes. Yes, because that does kind of go through what just put it in the chat room for anybody that was looking. So a list comprehension to grab all the resources if they're not there already, and add them to the task. I will accept that for that program because, yeah, that's, it does do it. I was expecting I was thinking of filtering. So not necessarily everything, but more specifics. But, basically anything, the two things, the main concepts was inheritance. So make sure you have inheritance and polymorphism so that, like you have there in that list comprehension mark, the resources, your main method is set up for resources. So either of these child classes can be applied there. And then a generator or list comprehension somewhere. That's kind of what I was looking for, but what you have there, I will accept. Because you did put together a list comprehension that goes through your test case and does some stuff. It kind of just grabs everything, but it's the proper syntax for a list comprehension. So I will say that's good for now. Any other questions? Okay, I assume that means no questions, so we're already past our time. I'll see you all on Tuesday. Let me know if any questions show up. Don't worry about late penalties on that. You want to take a little time, if that hasn't got working yet. And yeah, I will see you all on Tuesday. Y'all have a great weekend.